This video is brought to you by Career Designer 360. To know more about us, kindly log on to www.careerdesigner360.com. So today we will be talking about balancing chemical equation. So before knowing how to balance a chemical equation, it is very necessary for us to know what is meant by a balanced chemical equation. An equation is said to be a balanced one when the number of atoms of elements in the reactant side is same as the element in the product side. We can further see this statement with the help of this equation. Here zinc reacts with sulfuric acid to give zinc sulfate and hydrogen. We can clearly see that the number of atoms of zinc, hydrogen, sulfur and oxygen on the both side of the reactant side and product side is same. For example, there is 1 zinc, 2 hydrogen, 1 sulfur and 4 oxygen on the both side. Hence we can easily conclude that this is a balanced equation. Now the question arises, why it is necessary for us to balance an equation? All the equations, all the chemical equations are guided by a law, namely law of conservation of masses. It states that the total masses of the reactants is always equal to the total masses of the products, or there is no mass that is created or destroyed in a chemical reaction. We can understand it with the help of this example, where 2 molecules of hydrogen react with 1 molecule of oxygen to form 2 molecules of water. Here we say that 2 molecule of hydrogen, that is 4 gram, this is the molecular weight, and 1 molecule of oxygen, that is 32 gram, reacts to form 2 molecule of water, that is 36 grams. Now we can easily see that the total mass of the reactant is equal to the total mass of the product, that is 36 gram. However, this law is not applied to each and every equation. There are some exceptions to this law. For example, in all the nuclear reactions, some of the mass is lost due to its conversion into the energy. The amount of energy released can be found out with the help of an Einstein equation, that is E equals to mc square, where m is the mass which is lost and c is the speed of light square. Now what can be the different types of question that can be framed from this part? There can be 3 types of questions which can come. The very first being simply balance the equation. In this type of question, you have to simply balance the equation, and chemical equation will be given to you where the number of atoms of elements of different elements is different in the left hand side and on the right hand side. So what you have to do is you have to chalk out the differences and then you have to balance it. You have to make the number of atoms same. For example, here we have 2 atoms of oxygen on the left hand side, whereas 1 atom of oxygen on the right hand side. Thus what we have to do is add a stoichiometric constant 2 in front of magnesium oxide on the right hand side and 2 in front of magnesium on the left hand side or the reacting side. So this is the very first type of equation which can be framed. The second type of question will be, you will be given with the reactants and then you have to form the products, further balance the equation. For example, the equation in the red part is your question. Sodium sulfate reacts with barium chloride to form so and so. So the product part won't be given to you and you have to form the products from your reactant side. This is a double displacement reaction where sodium will displace barium from barium chloride to form common salt, that is NaCl, and a product barium sulfate will be also formed. Here once you know the product, you have to then balance the equation, which can be done by adding a stoichiometric constant 2 in front of NaCl, which makes the number of atoms of all the elements same in both the sides. Coming to the third or the last type in which question can be framed. So this is the most difficult one. Here you have to write down the chemical formula for different chemical compound, and then form the products and then balance the equation. As the example goes, zinc plus silver nitrate. So what you have to do, you have to first write down the symbolically these different chemical compounds. For example, for zinc you can write Zn, for silver nitrate you can write AgNO3, and then you have to guess the or form the products, which will be zinc nitrate plus silver. Once you are done with your forming products, then the question of balancing comes in, and you can do it by simply equating or counting the number of atoms of each element on each side and then making it same by adding stoichiometric constant. Now, learning how to balance the equation. To learn how to balance the equation, we have to follow 3 basic steps. The very first one is that you have to know the valencies of different elements very well. So we have a table present here which states hydrogen has a valency of +1, sodium +1, silver +1, potassium, barium 2+, calcium, and then we have some anions where it is fluorine F-1, hydroxide, nitrate, oxide O2-, sulfate SO4 2-, sulfide S2-, and so on. So we can see there are numerous cations and anions for which the valency can be learned. These are some important ones, although you can find a PDF file attached along with some of the worksheets in the description of this video, where you can practice the balancing the equation and learn the valencies for different formula. Now, once you know the valencies well, your second step will be practicing to write down the chemical formula of various compounds. For example, let us take magnesium oxide. For magnesium oxide, magnesium can be represented by Mg, its valency is 2+. Oxide or oxygen, it can be represented by O, and its valency is 2-. So we know that all the elements combine with each other or react with each other in a whole number ratio. So what will happen? 2 will cancel out, and there will be a crisscross of valencies or the whole number ratio, which will result in MgO. Now the next example is ferric oxide. You must also note that there are some elements which show more than one valency. For example, iron. Iron has 2 different cations, ferrous and ferric. When we say ferrous, it means that it has a valency of +2, whereas when we state ferric, we mean that it has a valency of 3+. Now, since here we have ferric oxide, it means that we will take Fe3+, and for oxide we will take O2-. Now there will be a crisscross of the valencies, and it will result in a chemical formula of Fe2O3. Now you must note that you can't form chemical formula for all the compounds. For example, there can be sulfuric acid. Now you will be confused that how to make a chemical formula for sulfuric acid. So you have to learn the chemical formula for all the acids, namely nitric acid, sulfuric acid, hydrochloric acid, hypochlorous acid, and so on, carbonic acid, and there are many acids. You can find it in a worksheet. Then coming to zinc sulfate. For zinc, we can represent it from Zn 2+, and for sulfate it's SO4 2-. Again, 2 will cancel out, and it will result in a formula ZnSO4. Finally, we have sodium bicarbonate. Sodium will be represented by Na+1, and bicarbonate will be represented by HCO3. minus 1. It will result in a chemical formula NaHCO3. Now, once you have learned how to make chemical formula from its chemical name of chemical compound, we come to balance the equation, or we learn to balance the equation, actual balancing. So we have HNO3, that is nitric acid, plus calcium hydroxide CaOH2 reacts to form calcium nitrate and water. In this equation, we have to see that this equation corresponds to the very first type of a question set which we have discussed earlier. So all the reactants, all the products, the whole equation is given in a equation form. Now what we have to do is we have to make a table. We have to check the number of elements in both the side, and then we have to balance. For example, here in this equation, the number of hydrogen in HNO3 or nitric acid is 1, nitrogen is 1, and oxygen is 3. For calcium hydroxide, it's Ca, calcium is 1, oxygen is 2, hydrogen is 2. So we write it in the blue section, which is the reactant side. Now in the product side, it is given in the yellow section, that is 1 calcium, 2 nitrogen, 6 oxygen, 2 hydrogen, and again 1 oxygen. So we can see that there is a clear mismatch in the amount of, or the number of atoms in the left hand side as well as in the right hand side. The number of oxygen atoms in the left hand side corresponds to 5, whereas in the right hand side corresponds to 7. There is a clear mismatch. The number of nitrogen is 1 in the left hand side and 2 in the right hand side. So what we will be doing, we will be adding some stoichiometric constants. What we can do is multiply nitric acid with a stoichiometric constant of 2 and multiply H2O, that is water, with a stoichiometric constant of 2. So this makes our equation a balanced one. Now we have 4 hydrogen both the sides, 8 oxygen both the sides, 2 nitrogen both the sides, and 1 calcium both the sides. Now the second equation which we can go through is barium chloride plus aluminum sulfate gives barium sulfate and aluminum chloride. This is also an example of double displacement reaction. Here again we'll be drawing a table which states the number of atoms on the both sides, and then we'll be multiplying with the stoichiometric constant. So we can multiply in this section, we can multiply barium chloride with a stoichiometric constant of 3 and barium sulfate with the stoichiometric constant of 3 and aluminum chloride with 2. This gives us a balanced equation. Now on comparing both the sides, we have 3 atoms of barium, 6 atoms of chlorine, then we have 2 atoms of aluminum, 3 atoms of sulfur, and 12 atoms of oxygen. Hence this is a balanced equation. Now the other example is a type of third one where we have to although we are given with the products, but we are not given with the chemical equation. We are rather given with the equation in a form of chemical name, zinc plus silver nitrate. So we have to represent this whole equation in a form of symbols, and then we have to go to the balancing part. So for zinc we can write Zn, for silver nitrate we can write AgNO3, for zinc nitrate we can write ZnNO3 bracket 2, and for silver it is Ag. Again, we make the table. We write all the reactant part in the blue section, all the product part in the yellow section, and then we multiply AgNO3 with 2 and silver Ag in the product side with 2 to balance the equation. Now, finally, we have one more example with us. Calcium hydroxide plus carbon dioxide gives calcium carbonate plus water. For calcium hydroxide, it will be CaOH2 plus CO2 gives CaCO3, that is calcium carbonate, and water H2O. So we again make the table. So we have 1 calcium on the left hand side, 2 oxygen, 2 hydrogen in calcium hydroxide, and then 1 carbon and 2 oxygen in carbon dioxide, which is written in the blue section. And then on the right hand side, which is in the yellow section, on the product side, we have 1 calcium, 1 carbon, 3 oxygen, then again we have 2 hydrogen and 1 oxygen. To balance the equation, we can multiply the equation. So we don't need to multiply the equation, since we observe that the number of atoms of element is already balanced. So this is already balanced one, and we don't have to balance this equation since the number of atoms are same on the both side. This type of question can also come, no wonder. However, this type of question comes less frequently, where your question will be already balanced. You don't have to balance the equation, but you have to just convert it from the chemical formula. Thank you for watching the video. I hope this video contributed to your knowledge. You can go in the description section to find worksheets and the Valency sheet.